This demo's problem 6 from chapter 3, and in that scenario we were pretending that if Austin Powers made a new movie in 2010 and he held the earth for ransom for, let's say, $30 million, the question was what inflation rate would be equivalent to a value of about $4 million in, actually I'm going to make that $3 million in 1970. And again, I'm using different values than appear in your problem so that you'll have to work this yourself. I'm just trying to demonstrate the process. So the $3 million in 1970 compared to the $30 million in 2010 is a present value. So even though the year is not currently 1970, the $3 million occurs prior to the $30 million, making the $30 million a future value relative to the $3 million present value. And the question was, again, what rate would equate those two numbers? So basically, if you took $3 million in 1970 and increased it at some annual rate every year for 40 years, what rate would that have to be to make it equal to $3 million? We can use the future value equals present value times 1 plus rate, or I, to the power of time, or n, to solve for this. We would input the 30 million as the future value. Since both the 30 million and the 3 million are in millions of dollars, there's no need for me to actually write all those zeros. I can just divide by a million, both values by a million, and make it 30 and 3 million. What I don't know is the rate, but I do know that n, or time, is 40 years. So what I want to do is solve for I. So I'm going to divide both sides by 3. Then I get 10 equals 1 plus I to the power of 40. And then if I take the 40th root of both sides, then I would get the 40th root of 10 equals 1 plus I. I'm going to pop over to my financial calculator and solve for the 40th root of 10. So 10 raised up to the power of 1 over 40. And I get 1.05925 equals 1 plus I. And then I can subtract 1 from both sides, and I get 0.05925 equals I. So the rate is approximately 6%, or 5.925%. Now that's kind of a pain to do using an equation, so I'm going to toggle over to a financial calculator, the same one we've been using, and work it that way. So again, it's under Chapter Resources and the Interactive Financial Calculators, and scroll all the way down to the bottom. This time, because we're solving for a rate, there's this weird rule that you have to use whenever you're solving for a rate or time. You have to have what we call a sign change over here in the left column. So basically you have to enter one positive number and one negative number. It doesn't really matter in this case which one we enter as negative, so I'm going to enter the 3 million as a negative value. And again, I don't have to enter all the zeros. I could, it really doesn't matter. And I'm going to enter the future value as a positive value. So I could enter minus 3 million and plus 30 million, or just minus 3 and 30. There's no payment, so I'm going to enter a 0, and then the time, or number of periods, was 40, and I'm solving for the rate. So I just click rate, and I get 5.93. And just to show you, I could enter a positive 3 and a negative 30, and solve for rate again, and it will give me the exact same answer.